Hi class, this is chapter 9-2 on sequences. We're going to take a little bit of a break from graphs and we're going to do some work with sequences and functions, and then we're going to be learning how we can graph those. Okay, this one's going to be a little bit of a fill in the blank. These are skeletal notes. We're going to be talking about a sequence. So, sequence means a set of numbers, should be an S here, that follows a pattern. The numbers 1, 3, 5, 7, etc. form a sequence. Notice that we use 3 dots. After the 7 there's a comma and then dot dot dot. That means the pattern continues. The numbers 1, 3, 5, 7, and so on, which is what those 3 dots really mean, and so on, are what we call the terms of the sequence. The 1 is called the first term, the 3 is called the second term, the 5 is called the third term, the 7 is called the fourth term, and so on. There are different types of sequences, and one of the types that we have is called arithmetic. Arithmetic. An arithmetic sequence means that we add the same number to each term. We really cannot subtract. Students want to tell me, oh, I subtract 2 every time. But we really don't do that. We really cannot subtract with arithmetic because by definition we're supposed to add. What we do, though, is we add negative numbers. This goes back to the that's not the right way to spell numbers, is it? There we go. This really goes back to the fact that subtraction means to add the opposite. So if I'm going to subtract 2, that really means I add a negative 2. If I'm going to subtract 5, it really means I add a negative 5. So therefore, we can work with our subtraction idea, only we change it to adding the negative number. Let's look at some examples of the types of things you'll be asked to do with arithmetic sequences. They're going to ask us to write a rule to describe each sequence and then find the next 3 terms. So here we're going to be starting with 5. And in fact, that's the first words usually of my rule, is that we're going to start with whatever their first term is, in this case 5. Now we have to figure out what is done. How did I get from that first term of 5 to the second term of 10? I could have multiplied by 2, but is that going to work to go from 10 to 15? No, it's not. And remember, this is a section on arithmetic sequences. So I'm either going to go from 5 to 10 by multiplying by 2 or adding 5. So I look at the second term to the third term, 10 to 15. Is it going to work to multiply by 2? Absolutely not. It will work to add 5. So my rule is that I start with 5 and add 5 repeatedly. You're going to get very used to that word in this particular lesson. Now I also need to find the next 3 terms. Well, I'm adding 5 repeatedly. So 20 plus 5 gives me 25. 25 plus 5 gives me 30. And 30 plus 5 gives me 35. Now let's look at example B. I'm going from 12 to 7 to 2 to negative 3. Well, I know I'm going to start my rule by saying start with the first number that they give me in the sequence. So I start with 12. And then I'm going to do something to the 12. Well, how do I get from 12 to 7? That will also work to get me from 7 to 2. Here's where a lot of you are going to say, well, you subtract 5. But remember, we do not subtract. We add the negative number. Subtracting by 5 means add a negative 5. And we're going to do that repeatedly. Now I need my next 3 terms. Well, negative 3 plus negative 5 is negative 8. If I add negative 5 to that, I'll get negative 13. And if I add negative 5 to negative 13, I get negative 18. Notice that in this lesson, we're going to be going all the way back to what we did in chapter 1 this year of integers. Another type of sequence we have is geometric. By definition, geometric says I have to multiply each term by the same number to get the next term. Now, multiply. Multiply. I can't divide, I'm supposed to multiply. But sometimes students want to say, oh, well, you must divide here. Yes, you maybe do, but we don't use divide. Let's look at example A. Just as with arithmetic, I'm going to start with 2. And then I'm going to have to multiply since it's geometric. Now I need to look at my numbers, my terms. 2, 4, 8, 16. What do I multiply by 2 in order to get 4? Can I multiply 4 by that same number to get 8? It should be pretty apparent that you multiply by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we multiply by 2. And there's that word again. Repeatedly. Now I need the next 3 terms. So 16 times 2 is going to be 32. 32 times 2 is 64. 64 times 2 is 128. Well, B is one of those where if you look at it, the first thing usually pops up in people's heads is, Miss Scouten, come on. You divide by 3. But remember, the definition says we have to multiply. We cannot divide. What we do is multiply. This one's going to blow your mind a little bit. By the reciprocal. So if you want to divide by 3, you have to multiply by 1/3. Remember that 1/3 is the reciprocal of 3. If you remember back to doing fractions, in particular, we said that you have to multiply by the reciprocal of the divisor. So instead of dividing by 3, we're going to multiply by its reciprocal of 1/3. So our rule here is to start with 27. And multiply by 1/3 repeatedly. And this is where sometimes students have a hard time, because I've taken 27 times 1/3 to get 9, 9 times 1/3 to get 3, 3 times 1/3 to get 1. Now I'm going to take 1 times 1/3. So the next term is going to be 1/3. Now here we go back to, do you remember how to do fractions? I'm supposed to take 1/3 times 1/3. Remember that when you multiply fractions, you multiply numerators and then over denominators. So 1 times 1 is 1, and 3 times 3 is 9. Can you get the next term if you're going to multiply by 1/3? Yes, it's 1/27. Now, where did it go? Okay, here we go. Now, We really say that we have arithmetic sequences, geometric sequence, or it doesn't follow for either one, so we call it a neither. And what we're going to do is just write the rule here. So we're going to go and look at A. We're going to identify it first of all, whether it's arithmetic, do we add something every time, or geometric, do we multiply by the same number every time, or neither, which means we either don't add the same number every time, or we don't multiply by the same number every time. And then we're going to have to write the rule. If we look at this first example, 2, 5, 10, 17, 26. There's really no way to go from 2 to 5 that will also work for 5 to 10. In fact, here they've added 3, then they've added 5, then they've added 7, then they've added 9. So this is called a neither, because you are not adding the same number every time. So we will start with 2. And we're going to describe what they did and add 3, 5, 7, 9, etc. You look at letter B and see if you can figure it out. Yes, I'm going to start with 4. And multiply by -2 repeatedly. That is going to make this one a geometric sequence. Okay, again, hit pause and you see if you can do the next 3, and then I'll show you the answers. Okay, in C we have a neither because we're starting with 2. And we add 1 to get 3, and after that, we multiply by 2, and we do that off and on. Add 1 times 2, add 1 times 2, add 1 times 2. In D, that is arithmetic, we're going to start with 9 and add -1 repeatedly. E is a little tricky, it's a neither, and really what we have here is 1 squared, 2 squared, 3 squared, etc. And that concludes Lesson 9-2. Catch you next time.